Hello, my name is Jake Oken, and I'm from ACE Robotics FTC team number 15430. Today we'll be discussing the importance of CAD and 3D printing in a robot design. To start off, let me tell you a little bit about our team. We are ACE Robotics FTC team number 15430. We're from Scottsdale, Arizona. We have created 4 total full CAD robots for competition. We have competed in both FTC and FRC using custom robots that we CNC'd, laser cut, and 3D printed pieces on. We have taught 14 different CAD workshops to FTC teams over the past 2 years, and we are experienced with 4 different types of CAD software programs that we will talk about later in this presentation. This presentation will cover the robot design, which is the basic design cycle, what is CAD, which will basically give you an introduction to CAD and robot design, which includes blueprint sketches, 3D modeling, and successful robots that have used CAD, as well as 3D printing, types of 3D printers, filaments, where to buy 3D printers and when to 3D print parts, as well as examples of 3D printed parts. First, let's start off with the robot design and the basic design cycle. The 3 steps to the basic design cycle include planning, prototyping, and finalizing your design. When you plan, you generate ideas for a part that you're building. So these are basically the ideas that you want to build. What do you want to do? How do you want to do it? And how are you going to get the job done? Next is the prototyping phase. This is when you experiment with those ideas that you've brainstormed. Prototyping can be with everything from 3D printed parts to prototyping with cardboard. Next is the finalizing phase. This is where you improve the prototype phase and implement it on the robot. So this can be with metal, wood, even 3D printed parts. Basically anything you can that you want to use on your final robot. So you may be wondering, where is the CAD and where does it fit into the design cycle? Well, that's what we're going to talk about right now. CAD fits into the design cycle because in the planning phase, we start out by creating blueprints to help you in the prototyping phase. So this is when you can basically say, how do we want this robot configured? Then you can basically take 2-dimensional sketches and you can actually make them into a CAD design. And with the CAD design, you can actually see how the robot's going to look and how it would move and function, which would move you into the prototyping phase. In the prototyping phase, you're going to actually model the parts to ensure that they fit on the robot. So we don't want to see the robot where all the parts don't fit onto the robot. So that's why we use the prototyping phase. Next, we finalize. So this is where you make a 3D model of your entire robot. So when you make this 3D model, you can actually see what it's going to look like, how it's going to function. You can run stress tests. You can run any sort of test that you might want to see how the robot would operate under certain circumstances. That's where CAD fits into the design process. So starting off with the planning phase, you can see what we did for our 2019 robot, which we called Commander Spade. If you look up on your bottom left-hand corner, you can see our first drawing. This is a very rough drawing, but it's more detailed than the right drawing. So if you look on the right side, you'll see a drawing that is basically just a rough sketch. This was one of the first sketches that we did once we saw the game was released. Next, you can actually see on the left side, we started to put a little more thought into our design. So if you look, you can see that we kind of have some math on there. We have some diagrams and examples of how it's going to run. And that's basically how we went about the planning phase. Next is the prototyping phase. Before we even get our robot into CAD, we work on the prototyping phase. Some examples of the prototyping phase from our 2019 robot, Commander Spade, can be found on this slide. If you look over here on the bottom left-hand corner, you'll find 2 of our team members working together to frame our robot out of wood. So if you see, we have the normal metal drivetrain that we are planning on using that we built prior to the challenge, as well as the framed wood on top. So with the wood, we're able to attach different attachments to it and actually see how the robot is going to function. Then if you look on the right-hand side, it's our cardboard prototype. We had different students work on the cardboard prototype, and this prototype actually functioned with our intake that extended outward where we went into the crater and back. This worked well because we're able to see what the robot's going to look like as well as rough measurements. After we do these rough prototypes, we move into the CAD phase, and we design our robot on CAD to see what we want it to look like. During the CAD phase, it is crucial that you take it seriously because you might even have your final robot design in your CAD design. How cool is that? Next, we move into the finalization design. So the finalized design of our robot is what you see on the screen. This is a render of our robot that was CAD'd, and then we actually built it, and it worked out perfectly because we were able to use tests on CAD, and then we were able to make minimal changes after the fact. Now let's talk about an introduction to CAD and how it is used. Now you've heard us talk a lot about CAD and how we used it to design our robots, but what is CAD? CAD stands for Computer Aided Design. CAD allows you to use computer programs to create, edit, and test components for your robot. CAD is used for concept sketches, which are just basic sketches where you can see how your robot is going to work, renders, which are actually very cool and very intense pictures where you can see what your robot will actually look like, gravity tests, and so much more. At the beginning of our presentation, you heard that our team knows 4 different CAD programs that we use regularly. These include FTC Creo, SolidWorks, Autodesk Fusion 360, and Onshape. These CAD programs are very instrumental and help us greatly in the robot design process. All of the programs are great. We recommend SolidWorks because it's very easy to begin with and you can get free licenses for first teams. For our 2019 robot that you saw earlier, we used a mixture of SolidWorks and FTC Creo to design the robot. But all of these softwares are great and you can use any of them however you want to. So as we said earlier, we mainly stick to SolidWorks because we found that we are able to conduct higher level tests on it. Here are some examples of different SolidWorks techniques. So if you look over here, this is us making a bolt in SolidWorks. And this is an example of a bearing that we designed in SolidWorks. As you can see, you can make pretty in-depth sketches. This sketch specifically we rendered to look a little more like the real object that we would see in real life. If you would like any examples, please contact acerobotics15430 at gmail.com and we can send you some more examples of renders, CAD designs, and we can even CAD parts for you if you have any trouble. Now you've seen a lot of our CAD designs and how we implement CAD into our robot, including if you look on the right hand side of the screen, you'll see our robot for the 2020 season, Skystone. But what are the benefits of CAD compared to just drawing your robot out pencil paper? Well, it's easier to map out for template building. So this means that you can actually take templates, you can print them off, and you can actually cut them out by gluing it onto a sheet of polycarbonate, sheet metal, or even plastic. You can cut out two-dimensional templates to help you by hand, which is basically the same as the map out templates. And our personal favorite, the calculations are done for you. You don't have to sit there with a calculator and do them by hand. You can actually type them into the computer and they'll do it for you. It also helps because you can use shareable files, it's simple documentation for your engineering notebook, and it's easy modification. So if you don't like something on the robot, you can change it very simply. So why do we need CAD? Well, you can use CAD for strength analysis to see how strong your parts are, center of gravity calculations. So if you're building a climber or any other instance where you would need to calculate the center of gravity, you can do that easily on CAD. They're easy templates as we talked about before. You can 3D print and CNC parts, which is crucial, and we'll talk about 3D printing more later. You can use fit determination to determine how big your robot is and how you will fit all the parts into your small 18 by 18 by 18 square. And you have access to an online parts library, which makes CADing very simple and you don't even have to create most of the parts. Most FTC retailers such as GoBuilda, ServoCity, Actobotics, RevRobotics, and AndyMark have an online CAD library where you can actually download your own parts. Next, let's talk about CAD and robot design. So what applications of different CAD methods can you use? First, there's blueprint sketches. Blueprint sketches are two-dimensional models. To create a blueprint sketch, you're going to start by creating a part. Next, you're going to create a sketch. So a sketch is where you draw your part on CAD. But make sure you don't extrude it to 3 dimensions, because if you do, it's no longer going to be a blueprint sketch. This will help for assembly and fabrication because you can create parts with it, you can print off templates, and you can use them to cut out parts. Blueprint sketches can be helpful in chain calculation, custom hole pattern designing, and motor mounts. To start off with custom chain calculations, how many of you have used chains and realized that there's a gap or it's not tensioned all the way throughout the chain? I know we have on our team. By using CAD, you can actually draw a wrapped line around the center circular sprocket, and you can divide the distance by 6.477 millimeters. This will create the perfect chain tension. Next, you can create custom hole patterns such as Actobotics, GoBuilda hole patterns, or you can even create your own patterns. Motor mounts are big ones because they go hand in hand with chain calculations, and you can use the motor mounts with the GoBuilda series motors, Rev series motors, and DeMark series motors, or any other motors that you might use in FTC, such as Matrix or Tetrix. If you look over here, this is an example of a motor mount that we designed in CAD. This is an example of a two-dimensional sketch or drawing as you see in CAD that we talked about earlier. Now if you look over here, this is a render of a three-dimensional drawing in CAD of a robot. This robot utilizes all Actobotics parts which can be found on the ServoCity CAD library and downloaded and added into your design. If you look over here, this is a custom part that we used, which was actually a channel that we custom designed a hole pattern for. Now let's take a look at some other robots that have used CAD in their design. If you look at these robots, they're very complex, and without CAD, they probably wouldn't have had the same results that they had. These robots came from the 2018 Relic Recovery season, and as you can see, they utilize linear slides and intake mechanisms. Those are essentially how you create two-dimensional sketches. Now let's talk about 3D modeling. 3D modeling is just as it sounds. When modeling, make your robot as dimensionally accurate as possible. This will help you later. If you look in the top right-hand corner of the screen, you will see our 2019 Rover Ruckus Robot Commander Spade that you've seen before as a CAD model. If you see, the colors may be a little different because we wanted to make sure that you could see the contrast of different parts on here. Now, if you look directly below it at the arrow pointing below, this is our actual robot that we took a very high resolution picture of for you guys. As you can see, they're very similar, and because of CAD, we were able to have great results. I've said it again and I'm going to say it now. You do not need to recreate that one component. Check online. Most suppliers already have CAD models done for you. This means that AndyMark, GoBuilda, ServoCity, Tetrix, and more robot providers all have an online parts library that is free for you to download parts, and you can create your own custom assemblies with them. This is very important for any CAD designers who want to create a robot with commercial off-the-shelf parts. Now let's take a look at the different websites and where you can find the parts. If you look on the bottom right hand corner of the screen, you'll see a red square, and inside that red square you'll see different CAD parts that you can download. As you can see, they are designed in step files. Step files are files that can be opened in any CAD software and converted. This helps drastically because you can take any of their parts and create your own assemblies. This is the Tetrix website, but other retailers have it too. Let's take a look at the ServoCity website. As you can see in the red box closer to the right-hand corner of the screen, you'll see that ServoCity has the same step files available for download for their parts. There have been many successful teams who have used commercial off-the-shelf parts, such as ServoCity and Tetrix parts, in CAD designs to create their robot. Let's take a look at them. First, let's look at Team 6002 Basilix. If you look over there, you'll see they have Tetrix parts, so they've created a custom swerve drive. Swerve drives are pretty amazing and can be used in both FTC and FRC, but they do require a heavy, intensive use of CAD. But this is a great example of a COTS swerve drive. Next, let's look at Team 8375 Vulcan Robotics robot from the Rescue game. If you look over here, this robot does not look very different from the robot they used at the World Championships. That's because they were able to create this robot on CAD and then simply fabricate it very simply because of the CAD they used. Next, let's look at the 2015 FTC Block Party World Champions. This is Team 7013 Hot Wired Robotics. If you see, on the left-hand side of the screen, this is their CAD design. Now on the right-hand side, this is their actual robot that they used at competition. They look very similar, as do many other robots, and they were very successful because they were able to use CAD. In addition to Hot Wired Robotics, there were many other successful teams. Let's take a look at them. First, let's start with team number 724 Redneck Robotics 1. They were the 2015, 2017, and 2018 World Champions in Houston. They won the most World Championships out of any other team in FTC. How did they do it? Well, their design process goes like this. They start with 2 months of heavy, intense prototyping. Then they start with a push bot. So that's basically just a robot where they can push around and they can maybe even program it to move just to see how it would work on the field. Then they use the CAD process where they use blueprints, 3D models, and analysis, where they rely on CAD to build their final robot that they take to the World Championships. Another great team, Team 11115 Gluten Free, uses some great techniques in CAD as well. They were the 2018 finalist Alliance captains, and they were the Design Award winner. In 2019, they were the World Champions in Detroit, and they won the Control Award for their use of odometry and other creative thinking. In the design process, they used innovative, but now they're efficient. So instead of just innovating and trying to create the coolest robot, they realized that efficiency was key. So to do this, they start prototyping with Legos. By prototyping with Legos, they are able to successfully create a great robot. Then, in terms of the CAD process, they use blueprints where they use manual milling templates. So this means they're able to actually go take a template, they take a glue stick, they actually glue it onto a piece of polycarbonate or sheet metal. And then they use a jigsaw or some other various type of saw, mill, or drill press, and they're able to get exact cuts and measurements. This is useful for teams without a CNC router or 3D printer. Next, they use 3D renders of individual components. You'll see these renders on the next couple slides, but these renders are crucial because they're able to create very specific components and see how they will work on CAD, which in turn will see how they work on the actual robot. Now, this was essential for many of their important components, as you'll see now. Here is Team 11115 Gluten Free's relic mechanism. So as you can see over here, their intake starts where they intake the glyph, and then they're able to put it into a serializer type thing, as you can see over here. Now this grabs the 2 glyphs that they're able to score, and then as you can see, there's even Legos on their final prototypes, as well as 3D printed parts. They actually used this in the competition. Now, you can see how their robot came into play, because it looks exactly like the CAD design. Next, here's their relic grabber. If you look very closely, you can even see the strings that they use that are routed through the polycarbonate and into the servo. This helps them because they're able to actually see how the relic mechanism will turn out. The white parts are 3D printed, and the black part is the servo, and the rest of it is polycarbonate. Okay, I think we've talked enough about CAD and robot design. So now let's talk about CAD 3D printing and how you can use 3D printing in your robot. Let's start off with the types of 3D printers. There's COTS printers. Now COTS stands for Commercial Off the Shelf. Some examples of these are the common ones such as MakerBot, LulzBot, which you can see in the top right corner, and Monoprice, which you can see in the bottom right hand corner. And then you'll see that there's custom/kit. These ones are cheaper and often more powerful. We use a custom printer that we custom designed and fabricated so we're able to get more bang for our buck, as well as be able to print higher end filaments that require more heat to print. Now let's talk about the different types of filament. These include PLA, ABS, carbon fiber, nylon, and TPU and flexible. These are the main filaments that we've used on our robots. PLA, let's start off with. PLA is the most common and will probably be the most strength you'll need in FTC. PLA is great because it's a plant-based filament and it prints with very low heat. This means that you can use any type of 3D printer, whether it's custom or commercial off the shelf. Next is ABS. ABS requires more heat and you would have to use a better printer for. Now let's start to get into some more high-end filaments. Carbon fiber is a great filament for FRC teams and maybe even FTC if you need a really strong part that's light. Carbon fiber is great, but unfortunately you do need either a custom printer or a very expensive high-end commercial off-the-shelf printer, such as a Stratasys, that is able to print it. Nylon is very similar to carbon fiber and is actually used for bolts and 3D printing nuts. Then we have TPU and flexible filament. TPU and flexible filament can be used with most 3D printers that have a very hot nozzle and hot end, but they do require a heated bed because when the filament comes onto the tray, it has to be able to stick. We use TPU for different bumpers and various parts on our robot that we do not want it to be strong. An example of this is in our 2019 robot, we actually used a bumper type mechanism to block all of the shrapnel from getting into the gears. So many of you are wondering, are 3D printed parts really that strong? When should you 3D print parts? Well, you can 3D print any parts you want. With the right design, filament, and printer, you can 3D print almost any parts. We have 3D printed entire robots with either a custom printer with very low-end specs or a very low-end COTS printer. These include with PLA. So PLA is a great filament for starters and even rookie or experienced veteran FTC teams because you're able to 3D print very strong parts, but with the right design, you can 3D print it with any filament. Let's look at some examples of 3D printed parts. If you look on the left-hand side, you'll see a phone mount. Then in the middle, you'll see a pulley. A pulley is great because you can use the pulley either for a polycord conveyor, or you could even use it as a spool for stringing if you're using linear slides. Next, you can see actually a gearbox that you can print for FTC. Gearboxes I would only recommend printing with a stronger filament, but they have been done, and we've actually done them successfully. All three of these parts are important because we found them on Thingiverse, which is a free site where you can go and get free 3D printed parts that other FTC or even industry professionals have created. For more information on that site, or if you would like any specific 3D printed parts created out of CAD, you can go to thingiverse.com, that's thingiverse.com, or you can contact us at acerobotics15430@gmail.com. At the end of the day, what we hope you take out of this presentation is that you will start looking into CAD for your team, that blueprints really help with assembly and milling and have helped our team tremendously with hand-cut parts and custom-made parts with special machinery. Models are used to help out with assemblies. This means you can actually create assemblies as we talked about and make your robot on CAD. 3D printing can be a game changer for your team. I know it has for ours, and anyone can get started with 3D printing for very low costs and any team of any experience level. We want to thank you again for listening to this presentation and remind you that if you have any questions or if you need help 3D printing, finding a 3D printer, help with any CAD software, if you would like us to help you design a part or work with your team, you can find us at acerobotics15430@gmail.com. Thank you, and we hope you enjoyed this presentation.